Hello everyone, today our group will do the presentation about the applications of calculus in sport. At the beginning, I want to introduce our group members.
Giang Shui, Hua Ying, Elvin Bun Khai, Zhong Chuyin, Wong Jiaen, Ling Mingong, and Lu Letian. Introduction of calculus in basketball. First, history of sport in calculus. Calculating the statistic of game player winning percentage. Second, the relationship calculus in sport of basketball. Finding the exactly arc for shoot. Angle for releasing the basketball. Force that needed to apply toward the basketball. And the speed needed to fast break the defenses. Third, important and contribution of calculus in sport. Finding the most efficiency way to increase the result and provide a framework for modeling the system.
My name is Lim Hong. The metric number is 278426. Now I'll talk about the key concept. Key concept in our firm for sport related to calculus for our project are differentiation and integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process it makes when we find the instantaneous rate of change in function based on one of its variable. Differentiation in sport is an attempt to meet the need of everyone within a coaching session. This attempt is not a one-size-fits-all session, causing the same outcome to each player. Okay, so next, what is the integration? When a function fs is known, we can differentiation is to obtain its derivative df over ds. The reverse process is to obtain the function fs for knowledge of its derivative. This process is called integration. Integration is both in a set of unique and motor situations codified in a cooperative and competitive form in which people, with and without different types of diversity, both men and women, to rules, spaces, and the material switch to the skill and the potential of each, can participate activity and compete together.
My name is Hua Ying and my matrix number is 27823. Now I want to present the method that we use in this assignment. In general, we use the method of differentiation and integration to improve the performance of basketball result. Now let us discuss on the differentiation part. In mathematics, differentiation is the process of finding the derivative or the rate of change of a function. In this case, we apply on an equation of distance with respect to the time to get the rate of change of its displacement, and we call it as velocity. The formula of the velocity is shown in the diagram. Next, let us talk about integration. In mathematics, an integral assigns number to functions in a way that describes displacement, area, volume, and other concepts that arise by combining infinitesimal data. In this case, we apply integration on the arc length equation to get the distance of the pathway traveled by basketball, and the formula of the distance traveled by basketball is shown in the diagram.
The presenter, for example, is Elvin Bun Khai, Zhong Chuyin, and Wong Jiaen. In example 1, we use differentiation to find the maximum height and the time need for the maximum height. A projectile has an initial velocity 34.3 m/s and is launched 2.1 meter above the ground. First, find the maximum height in meter reached by the projectile. Second, how many seconds after the launch does the projectile reach the maximum height?
The formula for height h meter of an object propelled into the air is h equals to -1/2 gt squared plus v naught t plus h naught. G is the acceleration due to gravity, which is 9.8 meter/second squared. T represents the time in second, v naught represents the initial velocity as meter/second, h naught represents the initial height in meter. Here is the diagram which figure out from the information given in the question. The corresponding velocity formula for constant acceleration is v equals to -gt plus v naught, which differentiate from height formula. Since the initial velocity is 34.3 meter/second with initial height of 2.1 meter, the maximum height can be found when v equals to 0. Then substituting this data into the velocity formula and we will get t equals to 3.5 seconds. The object reached maximum height at 3.5 seconds after launch. Now, we substitute all data into the height formula and we will get h equals to 62.125. Hence, the maximum height is 62.1 meter and the time it occurs is at 3.5 seconds.
In example 2, we use differentiation and integration to find the arc length of a basketball throw. If the average velocity of a basketball throw is 2.24 m/s, the angle of release is 45 degrees, and the time required for the ball to travel is about 2 seconds, then find the arc length of the basketball throw.
Hi, so doctor, allow me to introduce myself. My name is Sqqm2043, which is metric number 276843. For the part that I would like to present is the example 2. For the horizontal and the vertical, there will be a different equation which is xt equal to x0 plus v0 cos theta t, while for the vertical one which is yt equals to y0 plus v0 sin theta t plus 12 gt2. Every symbol where they will represent different things, which is for the XO and YO, they will be representing horizontal and vertical position of the basketball respectively, while for the 0, which it will be the initial velocity of the basketball. The theta will be the angle of the ball is projected with respect to x-axis, which has been explained by my friend from the image, while the g will be acceleration due to gravity and having a constant value of negative 9.81 miles per second squared. T will be the time travel. So for the next one, for the value to be found, we need to find the derivative of xt and yt with respect to time t. So both of these values will be differentiated, while xt will differentiate with respect to time t will be obtaining v0 cos theta, while yt will be obtaining v0 sin theta minus 9.81 t. By using the arc length equation, the distance traveled by the basketball can be found. With a constant of L, we will integrate it using the upper limit of beta and lower limit of alpha as a symbol. Nextly, for the value inside, we will integrate it with v0 cos theta square it plus v sin theta minus 9.81 t square it under square root. So after that, we will insert the derivative of xt and yt in the arc length equation, and we obtain the value of upper limit of beta and lower limit of alpha integration with square root of v0 square 1 minus 19.62 v0 sin theta t plus 96.24 t squared. Since we obtained the value of v0 equal to 2.24 ms minus 1, the theta which is 45 degree and t is 2, those equations will be substitution into the equation. Hence, we will obtain the value of the length equal to 16.58 meters, which is integrate it and submitting the value into the equation. That's all. Thank you.
My name is Dang Xie, matrix number 278572. Let's look at the conclusion part. In this project, we have to identify the applications of calculus in sport field. At the beginnings, the key concepts in sports related to calculus in our project are differentiations and integration. Differentiation in sport is the attempt to meet the needs of everyone within a coaching sessions. Integration in sport is a set of ludic and motor situations codified in a cooperative and competitive form. Further on, the method that we use to improve the performance of basketball results is differentiations and integration. Afterwards, there is some example and analysis that complete by our group members. Firstly, is identify the maximum height reached by the projectiles and the time taken of the projectiles to achieve maximum height. Differentiation is applied in the calculation. We have found that the maximum height reached by the projectiles is 62.1 meter with the time taken of 3.5 seconds. Secondly, find the arc length of a basketball throw by using integration and differentiation. And we found that the arc length of the basketball throw is 16.58 meters. In short, we can know that calculus is useful in our daily life, which it can help athletes to reach their greatest performance. That's all for our presentation. Thank you for watching.